Hello everyone, I am Varun, Assistant Professor, Department of Mathematics, SJB Institute of Technology.
Hello everyone. Continuing differential equations solving series, we will look into few different problems today, kind of miscellaneous problems. At first, we have the problem given the equation d square y by dx square plus 2 dy by dx plus 10y plus 37 sine 3x is equal to 0. We are asked to find the value of y when x is equal to pi by 2. If it is given that y is equal to 3 and dy by dx is equal to 0 when x is equal to 0. So, in the first step, we are writing the given differential equation in symbolic form. One should also observe here that term containing dependent variable y are kept in left hand side and the term containing independent variable x is kept in right hand side. Observing the symbolic form, one can make out that this problem is solved by inverse differential operator of type 2, where phi of x is either cos ax or sin ax. Now, the first part of solving non-homogeneous differential equation is finding complementary function. So, for that we will be solving auxiliary equation, which is got by replacing capital D by m in the f of t. Okay, and here the roots are complex. After solving this quadratic equation, we got minus 1 plus or minus 3i, and the corresponding complementary function will be e to the power of minus x c1 cos 3x plus c2 sin of 3x. In the second part, we will be finding particular integral. As we have already told, it is sin 3x, it is of type 2. So, here d square will be replaced by minus of a square, which is the value is minus 9. Okay. So, in the denominator term, we will be replacing d square by minus 9, and simplifying that, I will be getting 2d plus 1 in the denominator term. Now, we are already aware that when we have 2d plus 1 or anything of the form alpha d plus or minus beta, we will multiply and divide by alpha d minus or plus of beta. So, with that in mind, in the next step, we will be multiplying the particular integral with 2d minus 1, and at the same time we will be dividing by 2d minus 1. The moment I multiply 2d minus 1 with the sine of 3x, one can easily observe that d represents d by dx, so sin 3x has to be differentiated. In the denominator, we can observe it is of the form a plus b into a minus b. So, in the numerator, 2d, when I say 2 into times 3 sin 3x, I will be differentiating that with respect to x. So, sin 3x gives me 3 cos of 3x. Of course, taking negative sign outside and simplifying it, I will be getting minus 37 6 cos 3x minus sin 3x, and in the denominator I already have 4d square. So, over there d square will be replaced by minus 9 as usual in the type 2 problem. Here we can observe both in cos 3x and sin 3x the value of a is 3 itself. So, d square is replaced by minus 9. And now, in my final solution, I will be adding complementary function plus particular integral. As we know, complementary function is e to the power of minus x c1 cos 3x plus c2 sin 3x, and on the other side we have particular integral cos of 3x minus sin 3x. Now, taking the solution as first equation, okay, same time we will be differentiating this. Now, equation 1 is differentiated with respect to x. The reason behind this is in our initial condition, we have been told that at x is equal to 0, dy by dx will also be equal to 0 and y will be equal to 3. So, keeping this in mind, we are differentiating equation 1, the solution which we obtained with respect to x. Now, considering the initial condition, we already know that y will be equal to 3 when x is equal to 0. So, in equation 1, we will substitute y is equal to 3 and x is equal to 0. So, this is giving us e to the power of 0 c1 cos 0 c2 sin 0 plus 6 cos 0 minus sin 0. You know sin 0 is 0 and cos 0 is 1. So, that gives us c1 plus 6 to be equal to 3. So, which implies c1 is equal to minus 3. So, from this we have gained the value of c1 to be equal to minus 3. And obviously, the other known value is dy by dx to be equal to 0 when x is equal to 0. So, substituting this in the derivative value, we are getting at y is equal to 0. Now, e to the power of 0 minus 3 c1 sin 0 plus 3 c2 cos 0 minus e to the power of 0 c1 cos 0 plus c2 sin 0 minus 18 sin 0 and 3 cos 0. Substituting the values of sin 0 and cos 0 and simplifying the term, we are getting the value for C2 to be equal to 0, right? And using C1 and C2 value in the equation 1, we will be getting solution in this form. Y is equal to minus 3 e to the power of minus x cos 3x plus 6 cos 3x minus sin 3x. Now our target is to find the value of y at x is equal to pi by 2. So in whatever solution we got at the end, we will be substituting the value of x to be equal to pi by 2. The moment I do that, as you know, it is cos 3x in all the inscribed terms, so it turns out to be cos of 3 pi by 2. So now I will be having minus e to the power of minus pi by 2 cos of 3 pi by 2 plus 6 cos 3 pi by 2 minus sin 3 pi by 2. So cos 3 pi by 2 is equal to 0 and sin 3 pi by 2 is equal to minus 1. Substituting these values, we will be getting cos of pi by 2 value to be equal to 1. So thus we conclude that y is equal to 1 when x is equal to pi by 2. Our target is reached in this problem. In the next stage, we will look into one of the interesting problem, d power 4y by dx power 4 plus 4y is equal to 0. Here, the given differential equation is homogeneous, and quite obviously we know that for homogeneous equation, complementary function itself serves as a solution. So the given equation, when the moment we write it in symbolic form, we will be getting d to the power of 4 plus 4 into y to be equal to 0, where d is d by dx. Now the auxiliary equation takes the form m to the power of 4 plus 4 is equal to 0. It is a fourth order equation. So what we will be doing is we will just convert that m to the power of 4 as m square whole square, and of course 4 we will write 4 as 2 square. We will add and subtract 4m square. Now on the other side, the first three terms can also be written as m square plus 2 the whole square using a plus b whole square logic, and minus 4m square turns out to be minus of 2m square. Now this is of the form a square minus b square, which can be split as a plus b into a minus b. So I am getting two different quadratic equations here, which is m square plus 2 plus 2m, m square plus 2 minus 2m. Both are being equated to 0. Now solving two factors, two quadratic equations using the same logic of minus b plus or minus b square root of b square minus 4ac divided by 2a, I am getting both two different complex roots for m, minus 2 plus or minus 2i by 2, and the other root is 2 plus or minus 2i by 2. Of course 2 can be taken out as common, and we can just cancel it by the denominator 2, and then we can observe both the roots are complex and they are different. So m1 will be equal to minus 1 plus or minus I, and m2 will be 1 plus or minus I. So our complete solution will now take the form e to the power of minus x c1 cos x plus c2 sin x with m1, right? And the second term e to the power of x c1 cos x plus c2 sin x with m2. So first term is with respect to the first root, the second term is with respect to the second root, and both the roots here are complex. Now in the next problem we will look into, of course, once again, method of variation of parameter d square y by dx square minus 6 dy by dx plus 9y is equal to e to the power of 3x by x square. The interesting thing over here is you can observe on the other side I have e to the power of 3x by x square. Somewhere I have like e to the power of ax as well as 1 by x square, which is polynomial form. So indirectly it is a combination of both type 1 and type 3, but they are multiplied together. Whenever it is multiplied together, we will solve it by variation of parameter. So auxiliary equation is written. Of course we are getting a quadratic equation. It's directly we can see it is of the form a minus b the whole square. So the root values are 3 comma 3, roots are real and equal. So the complementary function takes the form c1 plus c2x into e to the power of 3x. So when I have complementary function in that way, in the next stage I will just take out y is equal to c1 e to the power of 3x plus c2x into e to the power of 3x, and easily I can make out in my assumed solution au plus bv, where a and b are functions of x, I can just make out that u will be equal to e to the power of 3x, and v will be equal to x into e to the power of 3x. And from the given equation, if I make comparison with the general form, I'll be getting p to be equal to minus 6, q as 9, and r as e to the power of 3x by x square. So in the next stage, I'll be calculating the Wronskian. For calculating Wronskian, I'll be taking the values of u and v. Of course, for v, I'm supposed to apply product rule. And yes, in the first stage, I'll be having u and v. In the next stage, I'll be having u dash, which is 3 into e to the power of 3x, and v dash is 3x e to the power of 3x plus e to the power of 3x. Calculating the Wronskian, the determinant of that, I'll be getting e to the power of 6x as the Wronskian. Just like any other problem, we are calculating VR and UR, and yes, we got VR to be equal to e to the power of 6x by x, and UR to be equal to e to the power of 6x by x square. Of course, A formulation is given by integration of VR by W dx plus C1. Here we already know that W value is nothing but e to the power of 6x, and luckily in both VR and UR we are getting the numerator term as e to the power of 6x, so obviously they cancel each other, and the remaining term will be minus of 1 by x plus minus of 1 by x dx plus c1. So 1 by x integration turns out to be log of x, so a value will be minus log x plus c1. Continuing further, I have b to be equal to integration of ur by w dx plus c2. Of course, even here e to the power of 6x cancels. So 1 by x square integration is minus 1 by x plus c2. So of course, the integration is very simple. B value is minus 1 by x plus c2. Now in the general solution, which we assumed y is equal to au plus bv, we will substitute the values of a and b, and after simplification, it turns out to be y is equal to c1 e to the power of 3x plus c2 x e to the power of 3x minus e to the power of 3x log x minus e to the power of 3x. Once again, let me remind you, the first two terms are the complementary function. With this, we have come to the end of this session. We will be concluding this session for the day. So thank you for watching. Thank you for the patience. I will try my best to come up with some more interesting problem in the next stage. Thank you.